What are alkanes? They are the simplest organic compounds made of carbon and hydrogen only. Their general formula is Cn H twice n plus 2, where n is equal to 1, 2, 3 and so on. For example, if I put n equal to 1, then I have CH 2 into 1, 2, 2 plus 2 is 4. This one is methane. And if I put n equal to 2, I have C2H6. That is ethane. And for n equal to 3, I have C3H8. That is propane. Okay, now these are the lower members of alkenes, and you can put n equal to 4, then you'll get C4H10, that is butane, and so on and so forth. For methane, we have H. This is methane, and then ethane, and propane. We have 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this one is methane, this one is ethane, and this one is propane. Now, alkenes are also known as saturated hydrocarbons. Why? Because if you look from these structures, we see that there are many number of hydrogen atoms. So that means the carbon skeleton is saturated with hydrogen atoms. That's why they are known as saturated hydrocarbons. I hope it is clear. Why are alkenes known as saturated hydrocarbons? Because the carbon skeleton is saturated with hydrogen atoms. And also, they are known as paraffins. It comes from Latin word that is param affinis, and it means little affinity. Alkenes are known as paraffins. Why? Look here. If you look at this one, okay, forget about methane, look at ethane and butane, you'll see that we have C single bond C and C single bond H. These are single covalent bonds and they are stronger. So that's why alkenes are relatively chemical inert. Because of these strong bonds, alkenes are chemically inert. That's why they are known as paraffins, which means little affinity. Okay? Next, we come to the structure of alkenes. We are going to look only at the structure of methane and ethane, and it follows the same concept for the higher members of alkenes. Okay? Now first we come to methane. Now look here. For methane, the molecular formula is CH4. That is, we have carbon, hydrogen, 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 hydrogen. Okay, as of now, leave this one as it is. Now look here. What is the atomic number of carbon? 6. The orbital electronic configuration is 1s. In the ground state, it is 1s2, 2s2, 2p2. So we have 2 electrons, 2 electrons. 1, 2. Now in the excited state, one of the electrons jumps to this empty box. Okay, so we have 1s2, 2s1, 2p, 3. We have 1. Now this empty box has been filled by 1 electron. So we have in this way. Now what is this? This are the sp3 hybrid orbitals. Okay, and now for hydrogen, the atomic number of hydrogen is 1. Then what is the electronic configuration? It is 1s1. And you have to know here the structure for the s orbital is spherical in this way. And for sp3, okay, for this sp3 hybrid orbitals, it is like this. After knowing these two, go back to this one. Now draw for the sp3 hybrid orbitals like this. Okay, now for hydrogen, for the s orbital, it is spherical, so draw like this. Okay, then write this one as S, and for this one it is sp3. Okay, like this. The same way here, S sp3, and note that this part here are occupied by electrons. That means there is an overlapping of sp3 hybrid orbitals with the s orbital of hydrogen atoms. Okay, hence this is the orbital structure of methane. In the same way, if you have known how to draw the orbital structure for methane, you can easily draw for ethane too. That is the same way like this. Let me show it here. Now I'm going to show for ethane. So we have carbon, carbon, hydrogen, 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 draw the sp3 hybrid orbitals. Then now the s orbital. All these black colors are occupied by electrons. Okay, that is overlapping of sp3 hybrid orbitals with the s orbital of hydrogen. This one sp3, here also sp3. This one is s and this one is sp3. Okay, and note that here is sigma bonds. Okay, I hope it is clear how to draw the orbital structure for methane and ethane. Yes, okay, and after that, this is the orbital structure. Now you can also draw in this way. H, this is the tetrahedral structure. Now you might be wondering, why is this one having a tetrahedral structure and not in this way? Because if you look here, we have electrons, electrons, we have electrons here. That means there is a repulsion among the electrons. Because of that, we have a tetrahedral structure. And this angle here is 109.5 degree. The length of this one is 9.09 angstrom. Okay. In the same way, for ethane, here we have like this. The bond angle here is 109.5 degree. And this bond length is 1.54 angstrom. I hope it is clear. That's all. Thank you.